So we meet again, my favorite programmers, future architects, and engineers. Okay, so we're going to continue on to the chapter 3 of the book, The Object-Oriented Thought Process. This chapter basically covers advanced object-oriented concepts. And a quick heads up, if you are going to be programming in a higher object-oriented design kind of environment, you most likely don't need to know all this stuff. But if you're actually going to be involved in designing an object-oriented system, then it's pretty important for you to know these advanced concepts. Okay, so the topics that we're going to cover in this chapter are going to be constructors, overloading methods, error handling, scopes, multiple inheritance, and object operations. So let's get started. Now, what are constructors? Well, constructors are actually very special methods that run as soon as an object is instantiated. As soon as you instantiate an object, the constructor will run and it will execute whatever code you put inside the constructor. Most of the time, the constructors are used to initialize an object's variables, right? The attributes. Since the attributes contain the information about the object, you basically want to initialize all the variables to make sure that the object is stable. By stable, I mean attributes with values, even if it requires user input or some sort of use case scenario. So for that, I would use maybe a null value or anything. We'll cover this in a different chapter. So by default, every class has actually a default constructor. Obviously, this all depending on the language you are using, but for compiling languages, they will include a default constructor, which basically all it is just calling whatever inherits. And also when it comes to constructors, you could actually have multiple constructors. You could also have the first default, for instance, if you instantiate a class and you don't pass it any parameters or signatures, one constructor would run. But if you pass it a string when you initiate the class or instantiate the class, then it would run a different constructor. So basically what this does, it actually allows you to construct an object depending on the attribute that is initially passed to the object. Okay, so next is overloading methods. So this basically means that you can actually use different methods with the same name as long as they have a different signature or parameters passed into them. Now when using UML to model these classes, you won't be able to tell a difference by just looking at the diagram because they will have the same name. In order to find out what method does what, you would actually have to look into the code. Okay, so next is error handling. Now, although there's obviously different ways to cover this and to debug and to look for to handle errors differently, we're going to cover what's in the book and we're just going to stick to the topic. There's actually like a built-in conditional function called a try-catch block. You put the code that you think might cause any problems within the try block, right? And if it executes correctly, it will just skip the catch. But if any errors do occur, it would actually stop the execution of the try block and continue to the catch block. If you are looking for that exception that was caught in the try block, it would actually execute this code here. Next is scope, the importance of scope. It's important to understand. I will not be covering what scope is outside, like in general. I'll be covering what scope is when we're talking about it in the object-oriented concepts. There's three different types of scope levels. There's local, object, and class. Okay, so basically local attribute is basically when an attribute is only accessible inside of a certain method and anything inside of it, not anything on the upper level on the outside at the parent of that method. Okay, so next we got object attribute. Now this basically means that an attribute is only accessible within that certain object, and every object has allocated memory for that attribute. Okay, so now we got class attributes. Class attributes are basically when all the objects that were instantiated from a certain class share the same value. Next, we got multiple inheritance. Multiple inheritance is basically just like regular inheritance, and the only difference is that you could actually inherit from multiple classes. This is something a lot more complex. We're actually going to cover it in chapter 7. Now, last but not least, we got object operations. Basic object operations in programming become more complicated when you're dealing with complex data structures and objects. Knowing when to copy a reference or follow the pointer and copying it directly can help you create sub-objects. So that's it for this chapter. In the next chapter, we're actually going to be covering the anatomy of a class. We're going to start putting the pieces together. This is where it starts getting fun, so I hope you guys tune in.